another data structure called a mapping. So let's create this new data structure. So this data structure is going to be of type mapping. A mapping takes some type of key and spits out whatever variable it's mapped to. So in this case, if we're saying we want to use the name Becca to find her favorite number, we would say the string Becca is going to be mapped to the uint 256 favorite number. And similar to all the other variable declarations, the first part is going to be the typing. So this is going to be a type mapping of string mapped to uint 256. We're going to give this public visibility, and we'll call it name to favorite number. And without adding any other functions that work with it, if we deploy this, we can see we have this blue button because we're not making a state change, name to favorite number. And if we type in Becca in here, obviously nothing's going to happen because we haven't added this mapping in yet. So in our add person down here, let's even have this add person also add to the mapping. So we can do name to favorite number. And then the key is going to be this name. So of Becca, we're going to say we're going to map the name Becca to the favorite number. Now we're going to go ahead and compile. Again, I'm hitting Command S. Deploy. We can scroll down here. If we look up Becca in here, we're going to get nothing. However, if we add Becca and her favorite number being 24, this add person is going to add it both to the array and to this mapping. Now, if we look up name to favorite number, we see that Becca returns 24. Now, one other thing I want to show you guys, just because compilers are going to yell at you if you don't have them, is typically at the top of these contracts, you'll want to add an SPX license identifier. Basically, Solidity and the Ethereum community found out that trust in a smart contract can be better established if source code is available. And in terms of legality and copyright, it just makes life a lot easier if you add that license identifier right at the top of your Solidity. We're going to use the MIT license identifier because it's the most open license out there. It means, hey, anybody can use this code and we don't care. So you'll see a majority of Solidity contracts have this SPX license identifier, MIT at the top, and compilers will yell at you a lot less. Awesome. We now have a contract that we've decided that we liked. It's got mappings. It enables us to actually store people and their favorite numbers. This is fantastic. We've done all of our testing in this JavaScript VM, and we've decided, you know what? We want to deploy this to an actual testnet or an actual mainnet. How do we actually deploy this so that other people can interact with this contract? We are again going to use Rinkeby because that's what we use to make our first transaction. Now, again, you will need some type of test Ethereum in your testnet wallet. So again, if you get lost, you can always just Google Rinkeby faucet or Rinkeby testnet faucet and find a faucet. Or a better alternative would be to come to the link token contracts in the Chainlink documentation at docs.chain.link and scroll down or just look up Rinkeby. This link token contracts page has the most up-to-date faucets for any testnet that it supports. So for example, we get a testnet ETH faucet right here, which also just happens to be that exact faucet that we used earlier. The only thing you need to change in Remix is we need to change from JavaScript VM to injected Web3. And MetaMask will actually pop up and say, hey, would you like to connect to this application? Anytime you're working with a Web3 application or a web application that wants to access your funds or work with your MetaMask, MetaMask will pop up and ask for authorization first. This is really good so that we know which applications we're actually connected to. So we're going to go ahead and say next, connect, and we can see here that we've even connected here and that our account on the main network has 0 ETH. And Remix even tells us, hey, you're on the main network. So let's go ahead and switch to the Rinkeby network. And we can now see we're on the Rinkeby network and we have 17.74 ETH on this Rinkeby test network. Injected Web3 means we're taking our MetaMask and injecting it into the source code of the browser here. And that's the difference between injected Web3 and JavaScript VM. Web3 provider is if we want to use our own blockchain node or our own Web3 provider. When we do injected Web3, we're saying our Web3 provider is our MetaMask, which will work perfectly for what we're trying to do. So since we already have some tests on Ethereum, let's go ahead and deploy this and see what this would actually look like if we deploy to a mainnet. The process is going to be exactly the same, right? The only difference is we would be on the mainnet instead of Rinkeby. So let's go ahead, hit deploy. We'll uncheck published IPFS, hit deploy. MetaMask will pop up asking if we want to do this transaction, because remember, we are deploying a contract. We are changing the state of the blockchain, so we have to pay a little bit of gas fee for it. So we're going to go ahead and hit confirm, and we get a link to Rinkeby Etherscan, similar exactly as we saw before when we made a transaction. The difference here is that instead of sending Ethereum to somebody, we're actually making a transaction on the blockchain to create a contract. After a short while, it will show up here on Etherscan with a success, the number of block confirmations, which again is the number of blocks appended to the block that included our transaction. We see from, which is our account here, and we see to is this new contract that we just created. And we can even click it, and we see that there's this unique transaction hash that created a new smart contract. And same as working with the VM, we have all the exact same functions in here. And you can see if I hit retrieve, these three functions, since they're not making a state change, you can just click them and no transactions will be made. However, what do you think is going to happen if I hit store? If you guessed MetaMask will pop up, you guessed correctly. Again, we see the familiar pieces here. We have a gas price, gas limit. Go ahead and hit confirm. We get another transaction here. And once this transaction goes through, we should be able to call our retrieve function and see a new number. If we call it now, nothing shows up because our original transaction hasn't succeeded. But I bet if we look at it now, okay, it's still indexing, but it looks like it's been included. If we hit it now, we do indeed see this value here. And we can do the same thing with adding a person. We'll add Becca. We'll say her favorite number is 24. MetaMask will pop up. We'll go ahead and confirm the transaction. And if I look up Becca and the name to favorite string right now, it's going to show nothing because our transaction hasn't gone through yet. But if we wait a little bit, I should probably spell her name right, we do see 24. And if we look at the 0th index, we also see Becca's been added here as well. Now, all this Solidity code that we wrote, and when we interacted with this blockchain here, all this Solidity was compiled down to the EVM, also known as the Ethereum Virtual Machine. A lot of the blockchains out there today are what's called EVM compatible. And that means that all this Solidity and all these functions that we're creating can still compile down to EVM and deployed on their blockchain. You'll find out a little later when we look to work on a non-Ethereum based chain that we can still deploy our Solidity smart contracts to these other chains as well. But that's a term you'll hear more and more, the Ethereum Virtual Machine, or EVM. Now, take a break, give yourself a high five because you just deployed your first smart contract and you learned the basics, the fundamentals of Solidity. So huge congratulations on how far you've gotten. Now, in our second projects, we're going to take the fundamentals a step further and start going into the more of the intricacies of Solidity. But just as a quick recap, the first thing you always got to do in your smart contracts is name the Solidity version. Then you'll have to name your contract. A contract in Solidity is like a class and defines all the functions and parameters of your contract. There's many different types in Solidity, like unsigned integer, 256, Boolean, and bytes. We can create structs in Solidity. We can create arrays in Solidity. We can create mappings in Solidity. We can create functions in Solidity. View functions don't make a state change. Memory and storage are two different ways to initialize where a variable is going to be saved. All the Solidity code that we're working with gets compiled down to the Ethereum Virtual Machine. And last but not least, congratulations on taking your first step in learning Solidity. Let's move on to the next project. All the code, tips, and links that we're going to be working with can be found in our course repository. We can scroll down to Lesson 2, Storage Factory, click it here, and we can see all the code we're going to be working with. Good luck. All right, so we've done it. We've got our first contract out of the way. We're understanding some of the basics of Solidity. Now let's move onward. Let's get a little bit more advanced with what we're going to do with our smart contracts. And let's build what's called the factory pattern of smart contracts. So we have our simple storage contract here, which is great. It allows us to store numbers and store favorite numbers associated with different people, and this is great. What if, though, I want to have a lot of these simple storage contracts deployed? I want to give people the ability to generate and deploy their own lists based off of this contract. This is where the factory pattern comes into play. So let's go ahead and create a new contract. So in this contracts folder, I'm going to do new file. We're going to call this storage factory.sol. And now we'll have a storage factory.sol. Now, the way that we're going to do this is that you need simple storage and storage factory in the same folder. I have both of them in this contracts folder, but if you have them outside or in a different folder, that's okay. Just make sure wherever they are, they're in the exact same folder. So let's figure out how to get a contract to actually deploy another contract. We're going to add those basic pieces that we added in that simple storage.sol. We'll add the spdx license identifier, which will be MIT. We'll choose our Solidity version, which will be Pragma Solidity. And we'll say anything in the 6 range. And then we'll create our contract. We'll say contract storage factory, and we'll create our brackets here. And I'm going to do Command S or compile, whatever you want to do. Things are looking good here. Great. So how can this contract deploy a simple storage contract? Well, the first thing that we're going to need to do is actually import this simple storage into our storage factory contract. We need to import it so that our storage factory contract knows what a simple storage contract even looks like. The way that we can import it is by doing the command import and then the file path that the simple storage is located. So the file path for this is going to be at /simple storage.sol. This means that simple storage is in the exact same directory as storage factory. Doing this line is equivalent to copying everything in this contract bit, coming over to storage factory and pasting it above. You can even save and compile and have 2 contracts in the same file. Now, what's interesting about having 2 contracts in the same file is that when you go to deploy, you'll actually have a choice of which one you want to deploy. And it's the same thing if I do that import statement. So if I delete all this and I go back to import./simple storage.sol, in our deploy tab still, you'll see that we still have our choice of which contract we actually want to deploy. So this is how we actually import a contract or import any type of file that we want so that our contract knows what that contract looks like and can do. So if we want this contract to then be able to deploy a simple storage contract, we're of course going to have to create a function that can do that. So we'll do function. We'll call it create simple storage contract. We'll make this a public function. We'll do our little open and close bracket in here. The way we can generate a contract of simple storage type is by using a new keyword. So let's create a simple storage variable. We'll say a variable of type simple storage contract. We'll name this variable simple storage with a lowercase s equals new simple storage. What this line is saying is we're saying we're going to create an object of type simple storage contract. We're going to name it simple storage with a lowercase s. And we're going to say this is going to be a new simple storage contract. And we're saying this simple storage contract takes no input parameters. Of course, if we deploy this contract as is by going to our deploy tab, choosing the storage factory, staying on a JavaScript VM, deploying, scrolling down, we have this function that doesn't return anything. So we're creating new contracts, but we can't really read where those contracts are being created. We'd have to look on a block explorer like Etherscan or something. So let's make a way for us to keep track of all the different simple storage contracts that we deploy. Let's put them in a list or in an array. So what we can do is we can say simple storage